Yeah, welcome back to next session. In this, we are going to see about the data acquisition systems. These are the topics we have completed about the basics of signal conditioning. Now we shall start about data acquisition systems and its components. Data acquisition system consists of individual sensors with the necessary signal conditioning, data conversion, data processing, multiplexing, data handling, and associated transmission, storage, and display systems. So these are all the components, and these are all the systems involved in data acquisition system. Here in short, it is called as DAS also. Thus, data acquisition system abbreviated with the acronym DAS or DAQ. So it can in a few books you may find DAQ also. Typically convert analog waveforms into digital values for easy processing. The analog data is usually acquired and converted into digital form for this purpose of processing, transmission, display, and storage. Data may be transferred for long distances or short distances. The data may be displayed on a digital panel or meter or as part of CRT presentation also. So here the display panel, it may be a panel meter or it may be CRT presentation. Nowadays we have LED presentations. The same may be stored temporarily in either raw form or processed form for immediate use or for later references. So the data is should be processed by digital analog to digital converters, and then only data acquisition system can perform any action on this. So this is a typical data acquisition system block diagram. On left hand side, you can see the transducer stage. So here you number of transducers are connected, and for each transducer, output should be processed through signal conditioner. So a number of signal conditioners are connected here, and then the data is multiplexed in a multiplexer. So then the analog data is presented here. Then it should be A to D converter, or through analog data it can be recorded or it can be displayed, whatever way we want to present it. So through analog to digital converter, it can be sent to different processing units like printer, display device, magnetic tapes, transmission or storage devices for computer processing. So here computer processing, it can accept only digital signals and it can be processed. Those can be transmitted or those can be recorded or those can be stored also. So here sensors that convert physical parameters to electrical signals, signal conditioning circuitry to convert sensor signals into a form that can be converted to digital values. So A to D converters converts the conditioned sensor signals to digital values. So here the thus must acquire the necessary data at correct speed and at correct time. It must monitor the complete plant operation to maintain a line and safe operations. It must be able to collect, summarize, and store data for diagnosis of operation and record the record purpose. It must be flexible and capable of being expanded for future requirements. It must be able to compute unit performance indices using online real-time data. It must be reliable, easy to operate, and must be user friendly. So these are the those requirements. Configurations of DAS, it can be the important factors that decide the configuration and subsystem of DAS are as follows. Here, the number of channels to be monitored, sampling rate per channel, signal conditioning requirement for each channel, resolution and accuracy, cost. So these factors should be considered for configuring the DAS. The various general configuration includes signal channel possibilities. So it can be direct conversion, pre-amplification and direct conversion, pre-amplification, sample, hold and conversion, pre-amplification, signal conditioning and any of the above. So here any of the above functions also possible. You have to combine according to the use or according to your application. Multi-channel possibilities, multiplexing the outputs of a signal channel converters, multiplexing the outputs of signal hold circuits, multiplexing the inputs of sample hold circuits, multiplexing low level data, and also you require noise reduction options, filtering, integrating converters and digital processing. So here, these are the stages you can see here. The data acquisition is the process of using output signals and inputting that into a computer. So computer, once you send to computer, till that you are doing this data acquisition process. So analog and automated data acquisition systems. This system consists of a sensor, transducer, and output of which is connected to DAS board. So it is normally a PCB board, printed circuit board, through a signal conditioning unit. So you have a sensor, signal conditioner, DAS board, and then you have processor or computer output device. So output device can be a monitor, printer, or recorder. The dashboard is plugged in the computer. The dashboard consists of a multiplexer, amplifier, ADC, register, and control circuitry, and output is connected to the computer. So, a software employed to control the acquisition of data through DAC. When the program requires input from particular sensor, it activates the dashboard by sending the control word to the control and status register. The control word indicates what type of operation the board has to carry out. So the control word generated by the processor inside the CPU. So that will initiate or that will select what type of operation to be carried out. Automated data acquisition systems. Automated data acquisition system may take the following forms: data loggers, computers with the plug-in boards. So data logger is a it is also known as a recorder. Data recorder is an electronic device that records data over time or in relation to location, either with a build or in or via external instruments and sensors. Data loggers are available in various shapes and sizes. The data includes a simple economical single channel fixed function loggers to more powerful programmable devices capable of handling hundreds of inputs. So there are different forms of data loggers. Inputs from individual sensors, after suitable signal conditioning, it is fed into the multiplexer, which is then fed to the ADC. The output is then displayed on the digital meters. So here data loggers, you can see here, this is a data logger. For example, if you have a tachometer, a digital tachometer, you can measure the speed of any running wheel. So here when you are displaying the data there itself, then that system, that is a standalone system, so that is known as data logger. So that is one good example. You can see here, this is one such device. So it consists of different sensors and it processes data, and it displays data there itself, and the R that can be sent to data reading or SMS alert or storage device. So this is from Advanced Tech India Private Limited website. I have taken this diagram. So here, computer and plug-in cards, the different form of different inputs from sensors. You have signal conditioning, and then you have board, PCB board, and that is connected to computer. So this is plug-in cards, computer with plug-in cards. So single channel DAS. The system consists of a signal conditioner followed by an analog to digital converter performing repetitive conversions. So here it is single channel, means it is required the only one input, or one sensor is connected here, or one transducer is connected here. So this is the convert command from CPU, and the digital outputs are further fed to a storage or printout device, or to a digital computer for analysis. So if you see, there are many number of sensors are connected to multiplexer. So that is where you can have multi-channel DAS. The multi-channel data acquisition system can be time shared by two or more input sources. Depending on the desired properties of the multiplexer system, a number of techniques are employed for such time shared measurements. Multi-channel analog multiplexed system. The multi-channel DAS has a single A to D converter preceded by a multiplexer. The individual analog signal are applied directly or after amplification or as signal conditioning whenever necessary to the multiplexer. These are further converted to digital signals by the use of A to D converters sequentially. For the most efficient utilization of time, the multiplexer is made to seek the next channel to be converted, while the previous data stored in sample hold is converted to digital form. When the conversion is complete, the status line from the converter has to send a sample hold to return to the sample hold acquires the signal to the next processing station. On completion of acquisition, either immediately or upon command, the SH sample and hold is switched to the hold mode. A conversion begins after the multiplexer selects the next channel. This method is relatively slower than system where sample and hold outputs or even A to D converter outputs are multiplexed, but it has the obvious advantage of low cost due to sharing of majority of subsystems. So here you can see different channels, analog signal 1, 2, 3, 4, and you can see the scaling, amplification, signal conditioning units. So four analog inputs, four stations you have, and a single multiplexer. So from multiplexer, if through sample and hold circuit you are sending to A to D converter, and then buffer to a computer for transmission. So for A to D conversion, a logic function also can be applied. So this is a multi-channel DAS configuration. Multiplexing the outputs of sample and hold. So when a large number of channels are to be monitored at the same time synchronously but at moderate speeds, the technique of multiplexing the outputs of the sample hold is particularly attractive. An individual SH is assigned to each channel as shown in the earlier figure, and they are updated synchronously by timing circuit. The sample and hold outputs are connected to an A to D converter through a multiplexer, resulting in a sequential readout of the outputs. So this is the simultaneous sample system multiplexer. So you have analog inputs after signal conditioning. So you have different units here. So sample and hold circuits are a number of, depending on the number of inputs you are using, and all are multiplexed here. So you have A to D converter, and then you have timing, then interface, the interface, then the digital output is to be transmitted here. So this is a sample system multiplexer. So multiplexing low level data. A low-level data multiplexing system, as shown in earlier figure, enables the use of single high-quality data amplifier for handling multi-channel low-level inputs. Individual amplifiers are used for each low-level signal. Low-level multiplexing can be attractive when a large number of channels, it can be 25 also, all having low-level outputs, need to be used to moderate speeds. The use of individual channels is possible because of the availability of high quality amplifiers at moderate cost nowadays. A typical application is a 200 channel stress measurement system in a transmission tower setup. So this is an example. Several factors have to be considered to accomplish low level multiplexing successfully. Guarding may have to be employed for every channel, and each individual guard may have to be switched so that the appropriate guard is driven by common mode pertaining to that channel. So this is multiplexing, and also problems of pickup uh, gets more complicated and have to be taken care of to avoid the possibility of signal to signal and even common mode to differential mode signal crosstalk. So that is this problem is a common problem in multi-channel, and capacitance balance may need to be carried out when the number of channels to be multiplexed increases. The problem of stray capacitances and capacitive balance are worsened. In the specific case of 48 channel system, the input channels are subdivided into groups of 8 channels in the first tier. Each of these 6 subgroups are in turn multiplexed by a 6 channel multiplexer on the second tier. So this is the diagram in next slide. You can see here. So two other channels you can see here. This is it should be guarded properly, and differential input is given to the channels, and it should be protected to avoid stray capacitances. And you can see multiple switches, and then you have two other channels also you can transmit this. You have instrumentation amplifier, so it is a very good amplifier system for most of the instrumentation amplifier is utilized, and it is a beautiful circuit. It is given in the Rai Chaudhary book. You can refer detailed details about instrumentation amplifier. Sample and hold circuit, and then A to D, and then to buffer. So this is the multiplexing low level data. So, data loggers, the term data logger is used for DAC systems which are able to be used away from a computer. Once the program has been set by a computer, it can be put onto memory card, which can be inserted into a logger, or have the program downloaded it to it from a computer, so enabling it to carry out a required DAC functions. Data logger is a unit can monitor the inputs from large number of sensors. Inputs from the individual sensors after suitable signal conditioning are fed into the multiplexer. So this is data logger. The multiplexer is used to select one signal, which is then fed after amplification to the ADC. The digital signal is then processed by the microprocessor. The microprocessor is able to carry out simple arithmetic operations, perhaps taking the average of number of measurements. The output from the system might be displayed on a digital meter, and that indicates the output and channel number used to give a permanent record with a printer stored on a floppy disk or transferred to perhaps a computer for analysis. So this is a typical data logger system. You have thermocouple inputs and digital inputs to digital multiplexer, analog inputs to analog multiplexer, and you have for thermocouples there is a cold junction compensation is also required. So from that you are sending to analog multiplexer, and then sampled digital signal is directly sent to microprocessor, and analog signals should be processed to convert into digital signals, and you have an amplifier, and you have ADC, and ADC gives you the digital signals that will be sent to microprocessor. The gain controlled for amplifier, control signals for multiplexer are also sent from microprocessor. So here remote control and program input. So the output from the microprocessor can be sent to any of these devices: display, printer, floppy disk, and other systems. So data loggers, because data loggers are often used with thermocouples, not only thermocouples, it can be any sensor that produces analog output. There are often special inputs for thermocouples. These provide cold junction compensation and linearization. The multiplexer can be switched to each sensor in turn, and so the output consists of a sequence of samples. Scanning of the inputs can be selected by programming the microprocessor to switch the multiplexer to sample just a single channel, carry out a single scan of channels, to a continuous scan of all channels, or perhaps a periodic scan of all channels, say every 1, 5, 15, 30, or 60 minutes. So data loggers, typically a data logger may handle 20 to 100 inputs, though some may handle considerably more, perhaps 1000 also. It might have a sample and conversion time of 10 microseconds and be used to make perhaps 1000 readings per second. The accuracy is typically 0.01 percentage of full scale input, and linearity is about 60.005 percentage of full scale input. The crosstalk is typically 0.01 percentage of full scale input on any one input. The term crosstalk is used to describe the interference that can occur when the one sensor is being sampled as a result of signals from other sensors. So this is the cross talking. And here we have completed the data acquisition system and its components, and also data loggers. This is another topic, two topics we have seen here, and there ends the data acquisition system and data loggers. We will move to next topic in next session. Thank you, students. Thank you, students.